Hello again, it's Cliff here from Down Under. In this video I'm going to carry on with finish machining this very high value, fine tolerance prototype part. Well, thanks for coming back for part 2. Let's go on now and finish this part off with the various machining stages and tips and tricks along the way. I'd like to start off by showing you the part drawings and specifications, but you've got to be very careful about that. If you're quoting for a job, always think that the customer may well not want their intellectual property disclosed. So I'm not going to disclose who the customer is, or the drawings, or the specifications, or what the application for the part is. Just have to suffice to say it's a high precision prototype part. If you're machining a high value part, you really don't want to risk making a single mistake. You've got to be super cautious, and usually the supplied drawings are not based off machinist datums. The machinist datum is usually the end surface as the Z, so I like to do a little local specific drawing on critical machining operations. This is going to be a thread and a precision diameter. And I put the dimensions here based off the end for the digital readout, or if you're on a CNC lathe for your Z0 program, and my key diameters here. So it helps if you put the drawing on a clipboard near the work and in the orientation of the work. You don't want to be reversing numbers and drawings in your mind. You need to free up all the brain power you can for the actual job. Sometimes an alternate handed tool mounted in the front of the tool post like that gives you the best clearance for machining between centers, because the tool post is clearing away from the center here and gives you enough clearance there. It's a good idea once roughing is underway to remove the center and check that datum diameter is still concentric, because the machining process can release stresses in your stock, particularly if it's certain types of steel, heat treated steel or cold rolled steel. Aluminium's usually pretty good, and this doesn't seem to be letting go at all. There doesn't seem to be any stresses in there, so you can kind of move on a bit more relaxed, knowing that you've got a nice stable piece of material. Alright, so that diameter should be a high finish at 30.04. to 30.02. That's 30.03, that's correct. That thread should be 26.97, that's clearance on 27 millimeters. 26.97. Oh, it's critical work this. It's nerve-wracking. You know that with this sort of work you really can't afford to make a mistake, because it's one high value part, so you go really slowly and double, triple check everything. But the problem is that makes it even more of a high value part, and you've got even more to lose if you make a mistake and have to start again. So you're kind of on edge, and it should be stressful and an adrenaline process to keep you hyper focused, and in a way that's what I love about it. And when you finally finish and you breathe a sigh of relief, it's really satisfying to have made 100 critical machining operations without making a mistake on one of them. Another advantage of the rectangular block method with the flat datums is that I can check after I've done each stage. For example, here with parallelness, just over 0. Just before 0, about 1/100th of a millimeter, half a hundredth of a millimeter. So that's pretty well within 1/100th of a millimetre of parallel and central. That's really good. Whew. So far so good. Let's check it the other way. Alright, so we are 1/100th minus, 1/100th minus, so it's nice and perpendicular. One-hundredth plus, 1/100th, just over 1/100th plus, so it's very perpendicular, and it's about 1/100th of a millimetre off centre. That's less than half a thou off centre. Well, I'm happy with that. That's a big relief. Well, it takes a lot longer in the 4-jaw chuck setting by this method, but still it's not too bad. I'm coming in there to 20, spin it round. Yep, 20 that way, parallel that way. I was a little bit concerned with how critical it was that this dial indicator needle is in the middle of the part. So I've deliberately gone off 2 millimeters, and sure enough, it shifts the needle to 15 now, but it's still central, because now it's 15 on the other side. So the part's on an angle effectively, because the dial indicator is 2 millimeters off center, but it still works as a comparator between this rotary position and that rotary position. So it's still able to tell whether it's central or not, even though the dial indicator is off center, as long as you don't shift it in its X position between one measurement and the next. Although it's better if it's close to the middle, it doesn't actually affect it. So we're 20 there, 20 there. Now I've got to get it right the other way. So having those hardened steel parallels in the slightly curved jaw faces helps a lot to hold the whole thing in line and not impinge on the part. The system works a bit easier. It's a little bit easier to use if the stylus is as close as possible to the middle. You can line it up with a ruler and set your digital readout on 0. That's not difficult. In one direction, I needed to put a very fine shim under one end of the one jaw. It was beyond tapping range of getting it parallel, and that's probably an error in a jaw of the chuck or in the jaw slideways. While I'm on the subject of shims, if you want a big shim selection for a very low price, you can buy these cheap feeler gauge sets. You know, buy several of them. They're only, from memory, about $2 each on AliExpress. They take quite a while to get here to New Zealand, but it's good to have just for shim stock in a big wide variety.
And at that point, New Zealand was one of the most active countries.
Here's a quick tip for newbies. If you need to retract your quill because you're drilling a deep hole and slide the whole tailstock in, don't do that while the part is spinning on high value work, because if you slam the drill into the end of the hole while it's spinning, that puts a huge torque on the part and it could shift it. So after rough drilling, before I bore it out and machine the center for the reference datum transfer, I'm checking that nothing's moved. Because when you're machining, you're introducing vibration and pulses to the part and the chuck. And remember, the chuck are opposing jaws under tension, so it can settle into a slightly different position if you're unlucky, and you need to catch that if it's the case before you start to machine your reference center. Another reassuring double check is you can stop a thou away from the finished AF across flats diameter and look at the remaining section. I don't know if you can see it there. and they look really even and parallel. There doesn't have to be much out for it to look uneven. And after I've finished rough machining, I can put the dial indicator on that reference diameter that I transferred the datum surface to, and see whether it's shifted, see whether the material has let go any of its stresses or whether it's shuffled itself in the chuck a little bit. And it's just over 1/100th of a millimeter run out. That's 1/2 off center, you know, 5 or 6 microns. That's not enough to worry about. That's within the range of totally acceptable. Well, let's just double check we're still on accuracy track here. I've left a little bit on this diameter so I can chuck on it if it gets a bit scuffed and then finish machine it. But let's see how central it is. 21.5, 21, 22, 22, 22, just over 21.5. Well, that's great. That's within 1/100th of a millimeter. So we're still hanging on to that initial accuracy. Mentioned it before in other videos. I have my 3-jaw chucks all floating on their back plates. That is this clearance on the locating spigot, and you can just nip up the mounting screws and tap and get perfect concentricity with your 3-jaw. It's amazing how many people don't do that, and it's absolutely essential for doing accurate work. So now I can dial in central and parallel and just tap the chuck when it's eccentric in the high position against gravity, so you're tapping it down with the screws just nipped, and then you can tighten them up when you've got it accurately in position. So now I've set it up in my smaller lathe between centers. I've recently, or I will be, publishing a video on how to set the tailstock on your lathe accurately on center, and there's a real trick to that. You mustn't sweep it in with a dial indicator and then you'll be putting it in below center. There's a different way of doing it, and I produced a video on that. So I've got very accurate centers in this lathe, and that diameter there that I'm dialing now, I didn't quite finish turn. There's a few thou on it because I was going to be chucking the other end. I didn't want to mar it. But I'm really impressed how accurate the process is. You know, just before I finish machine it, about 1/100th of a millimeter run out. That's 5 microns error there off center. It's so accurate, and a credit to the aluminium. After all that machining, including that central hole, there's obviously very little stress in the material, and it's just stayed to its original shape. So now I'm just going to finish turn that diameter that I was chucking on. The other side is also running the same concentricity, so the whole thing is very accurate. I'm really relieved and pleased about that. But some of you might be thinking, well, why didn't you just machine the whole thing between centers? You know, and that was one of the options I was considering. The problem is that you're cutting threads and turning something down from square to circular. There's intermittent cuts there, and you've got to drive that somehow with some sort of drive dog that doesn't mar the already machined surface, and there had to be a lot of thought given to that. So I thought, no, I'll just machine it, holding it on the rectangular apart from this final check and machining of that diameter. So when you're initially planning the machining procedure for your part or parts, you need to think about all the different ways, you know, the manual machining methods and the CNC machining methods and how suitable it is. if possible, you want to do it by a CNC process that can be more automated. But that's very much dependent on the geometry of the machine surfaces and also the number of parts. Initially, the customer only wanted one part, one set of fitting parts, and so I couldn't justify CNC. There's a lot more setup time, programming, and double checking time with CNC. But if you, in this particular case, but if I had to make 10 of them, I'd do virtually everything that I could on a CNC lathe and a CNC mill. But because it was only one part, it was quicker for me to just manually machine the whole thing. And now I've finished it, the customer realized he actually needs two parts. So I would have used a slightly different procedure if I'd known that from the beginning to more efficiently process the machining stages, perhaps a little bit of CNC in some of the parts like the thread cutting and so on. But now that I have to make a second one from scratch, again, it's not worth working out the procedure for CNC and automating it. So I'll just play it safe and copy the exact procedure all over again. It will be quicker, but it won't be significantly quicker because I'm going to be manually machining the second one. So second time around, the first thing I'm going to do is carefully felt pen mark out the profile a couple of millimeters bigger than the part so I can bandsaw it out. Choice of material is very important here. This is a bit of 6061, but not all 6061 is equal. Very important to realize that you can get a very stable grade of 6061. I can't remember the code number of it, but you need to identify it as a machinist's grade of 6061, which is very different from an extruded 6061. Don't make the mistake of buying a piece of extruded 6061. You need to specify that you need machinist's grade, because the extruded 6061 is highly stressed, and when you machine it, it'll shift like a piece of wood, and you'll end up, if it's a precision part, wasting your time. You must get a machinist's grade. I think it's more of a cast process of making it than an extrusion process of making it. If there's any experts on the subject of the making of 6061, please put some comments in underneath this video. It'd be very useful for us all. During the manufacture of this part and a similar project, I've taken a lot of clips or scenes, and there's a lot of different tips and tricks, probably too many to put into one video. So I'll probably split them up into about 3 videos. So I'll finish this video up here, but please come back and have a look for future videos on this project. If you'd like to see more of this type of video, please remember to like and subscribe.